today's lesson I added a standard to our list. So this list was all from the ratios and proportional relationships section. This is actually a standard from the geometry section, but it has to do with proportional relationships, which is solve problems involving scale drawings of geometric figures, including finding length and area. So that's what we'll be working from over the next couple of days. This is the last thing we learn, and then we have a test on all of this stuff on Friday. Okay, so the first example, if you take a look in your notes, I'll read it from the notes. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he planned? Okay, and then we have here that this is a scale drawing, and it tells us that 1 inch on the drawing corresponds to 15 feet of actual length. So the units are not the same here because it's talking about 1 inch to 15 feet. However, if we're not being asked to find a scale factor here. We're just trying to decide if it fits onto the property. So we can use a scale ratio, which is not the same as a scale factor. A scale ratio is when we keep the units that are given to us and we just figure it out with those numbers rather than making conversion. The advantage to doing that is when we make conversions, sometimes the numbers are very large and they're just difficult to work with. So if we leave our units, we can still come up with a ratio using those units. So that's what we're going to do. For all of these problems, I'm going to have you make a table. So on the table, we're going to start with let's actually start, well, no, I've been telling you to start with the actual. Let's start with the actual. So let's put actual on the left, and let's put the drawing on the right. Okay, so first thing I'm going to put in the table is I'm going to take this from the description. 1 inch on the drawing corresponds to 15 feet of actual length. So I have my drawing in inches, my actual in feet. So my scale ratio for this would be what? What would the scale ratio be? Katie? 1/15. And I'm not going to call that a scale factor just because the units aren't the same, but the scale ratio, or our K, our constant of proportionality for this drawing is 1/15. Okay, now here's some other measurements from the drawing. On the drawing, we have 2 inches, and we have 1 2/3 inches, and I need to find the corresponding measurements on the actual court to see if it's going to fit in that space. How am I going to find the actual length in feet if I know that there are 2 inches on the drawing? What do I need to do to the 2? Tessa? Multiply it by 15. Good. When we go from right to left, we divide by the scale factor, and dividing by 1/15 is the same as multiplying by 15. You might also just look at it and say 1 times 15 is 15. So 2 times 15 is 30. And this one will probably take you a little longer to figure out. 1 2/3 times 15 is what? Someone said it. 25. So it's 25 feet. So the actual court will be 30 feet by 25 feet. So is it going to fit into the space that he wants it to fit into? Yeah, I see a couple nods, a couple people just blank Monday morning stares. But yes, if it's 25 by 30, it needs to fit into a space that's 25 by 75, so it's going to fit exactly along the one dimension, and then there will be room to spare along the other. Okay, if we were to find the actual scale factor instead of just the scale ratio, what would the scale factor be? Ava? 1/15 is the scale ratio because we have different units. To find the scale factor, everything has to be in the same units. So if I were to change feet to inches, put everything in the same unit, what would the actual scale factor be? Bella? No? No, we're still doing y over x, but x is going to change now. Ava? 1/180. There are 12 inches in a foot. If we take 15 times 12, we get 180. So now when we do y over x, it's 1/180. So the scale factor is 1/180. Using the actual scale factor gives us a better idea of comparing the drawing to the original. We know from the scale factor that the drawing is 1/180 or 1/180th of the original. Or it's easier to say the original is 180 times larger than the drawing. So it gives us a better sense of comparison, but when we're figuring things out here, it was a whole lot easier for us to multiply by 15 than it would have been to multiply 180, and it wouldn't have made a whole lot of sense to us to have the measurements for the actual drawing in inches. We would have had to have converted them back to feet anyhow. So what you use depends on what your purpose would be. If you're comparing the two, it's better to use a scale factor. If you're just trying to find dimensions, it's probably better just to use the scale ratio. Okay, any questions about that? Okay, let's look at example 2. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. Each square in the drawing measures 1 centimeter by 1 centimeter. Find the actual length and width of the garden based upon the scale drawing. So the garden is just this part in the center. This is just, the garden is placed on top of a grid, so it's like they took a picture of the garden and they stuck it on top of grid paper, which helps you measure the garden. So don't count the outside as part of it. These aren't stones surrounding a garden. Some people have thought that in the past. It's just a grid. Garden is just the inside. I would like you to make a table of the drawing to the actual, or actual to the drawing, just like we did here. We did actual and drawing. So I want you to do that. Make a table of actual lengths. I'm going to have to use some abbreviations here. To the drawing, and figure out the actual length and width of the garden. Okay, I'll give you a minute or two to do that. Okay, Connor with an E, what did you put as the length and the width of the drawing as in the picture? What was its length and width in centimeters?
8 and 4.
8 and 4. Okay, good. So on the drawing, along the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8. Along the side is 1, 2, 3, 4 squares. So it's 8 by 4. Hayden, what length in the actual garden corresponds to 8 centimeters in the 160, good. 160 meters. And Andrew, what length corresponds to the 4 centimeters?
80.
80. Okay, good. So that's all that it asked you to do, was to find the actual length and width of the garden. What would the scale ratio be, just based on the numbers we have in our table when we say the scale ratio is? This was not in the original problem, so I'm asking you this as something extra. Bella, how would you find the scale ratio?
15. Just 20 and
So what would it be? Would it be 20 or would it be 1/20? Y over x. So you want to start with the 1/20. So the scale ratio would be 1/20. If we're to find the scale factor, again, we need to be all in the same units. So there are, how many centimeters in the meter? Okay, 100. So if there's 100 centimeters in a meter, what would the scale factor be? Katie?
1.
1 over 2,000, good. 1 over 2,000, which is telling us, but the 1/20th doesn't really tell us a whole lot about comparing the two gardens, but this one does. This one tells us that the drawing is 1/2000th the size of the original, or it tells us the original is 2,000 times larger than the drawing. But it was definitely easier to use the scale ratio. I bet none of you found the scale factor first and then multiplied and then converted back, right? You probably all just looked at this and said, oh, this is 20 times larger, so I'm just going to multiply each of these by 20. Is that what everyone did? Yeah, so we wouldn't use the scale factor. In that case, we would just want to use the simpler scale ratio. Okay, another example. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. What will be the length and width of the tablet on the advertisement? So again, I want you to set up a table where we have the actual and then the scale picture. Okay, I'll give you a couple minutes to work at that on that, and just a heads up, I will ask you about the scale ratio and scale factor if you want to start thinking in those terms. Okay, let's start to go over this. So first of all, the first thing we should put in our table is the information that we have about the scale of the scale drawing. Allie, what would I put in for actual and scale picture here?
1 and 1/4, 1 on the actual, 1/4 on the
Good, 1 and 1/4. And she chose to say 1/4 instead of 0.25, which was kind of a smart thing to do because we are going to have to deal with fractions over here. So it's easier to deal with fractions than decimals, so we'll leave it as 1/4. And then we have 2 more dimensions for the scale picture, so I'm going to write those dimensions in. Now, is the scale ratio going to be the same as the scale factor or different from the scale factor? Will the scale factor and the scale ratio be the same, or will they be different? Kate, your name was next on the card and you're raising your hand, so go ahead and take that question.
It would be because they're not converted, they're still.
Right, there's no conversions to be made here. The actual is in inches and the scale drawing is in inches. There's no conversion to make, so when we find the scale ratio, it actually is the scale factor. It tells us how much smaller the scale drawing is than the actual, or how much larger the actual is than the scale drawing. Carly, what would the scale factor be? Not 1 over 0.25, it's y over x. The side's always y. So if we do 1/4 over 1, what's that? Yeah, it's just 0.25 or 1/4. So our constant of proportionality for this table is 1/4. Constant of proportionality is the same as the unit rate, and when we're dealing with scale drawings, it is the same as the scale factor. Assuming that we're in the same units. It's either the same as the scale factor or the scale ratio. So our constant of proportionality is 1/4. So if we want to get from here to here, from the right side of the table to the left side of the table, what do we need to do with that scale factor? Ava? Do what?
Do 1/8
Mhm.
times 1/4.
Not quite. When we're going from right to left, we do not multiply. When we go from left to right, we multiply. So when we go from right to left, what do we have to do? Emily? Divide. So we actually have to do 1 and 1/8. I'm going to do the work over here. 1 and 1/8 divided by 1/4. That makes sense because when we keep it, switch it, flip it. Actually, let me change that to improper fraction first. So we have less steps. We have 9/8. Keep it, switch it, flip it. I'm multiplying it times 4. That makes sense because the actual is 4 times larger than the scale. The scale drawing is 1/4 the size of the actual, So the actual is 4 times larger than the scale drawing. So I'm multiplying the scale drawing by 4 to find out how large the actual tablet is. So if I do 9/8 times 4 over 1, I can reduce before I multiply. I get 9 over 2, which would be 4.5 inches. Okay, any questions about that? Okay, to find the next dimension, let's see. Sammy, how would I find the actual length that corresponds with 1 1/4 on the scale drawing?
Wait, to find the next.
Yep, I want to find this. What? Yes, good. That's like a tongue twister on a Monday morning. 1 1/4 divided by 1/4. Okay, so if we do that, does anybody have an answer to that you'd like to volunteer? Ava?
5.
Yes, 5 is correct. Let's just run through the actual process to make sure everyone gets this. It would be 5/4 times 4 over 1. The 4s would reduce. We'd get 5 over again. So this would be 5 inches. Okay, questions? Okay, let's take a look at the exercise. We're going to read through it together, then I'm going to give you a chance to work on this. We are also going to do an exit ticket today, so we'll spend a little time on this, and then I'll give you the exit ticket. We'll be doing an exit ticket and our Get More Math quiz that we didn't do Friday during the lab section. All right, students from the high school are going to perform one of the acts from their upcoming musical at the atrium in the mall. The students want to bring some of the set with them so that the audience can get a better feel for the whole production. The backdrop that they want to bring has panels that measure 10 feet by 10 feet. The students are not sure if they will be able to fit these panels through the entrance of the mall, since the panels need to be transported flat or horizontal. So they can't lift them up, they have to go in the 10 by 10 way. They obtain a copy of the mall floor plan shown below from the city planning office. Use this diagram to decide if the panels will fit through the entrance. And it says here to use a ruler to measure. However, it already tells you that the mall entrance is 3/8 inches. So I'm not sure why it's telling you to use a ruler to measure, because it does give you that. You don't need to measure. You can just use the 3/8 that is there. And then if you look off to the side, it gives you the scale, where it says that 1/8 inch on the drawing. I don't have that up here. 1/8 inch on the drawing represents 4.5 feet of actual length. So that's what you would use as your first. So again, make a table just like you've done for the other problems. Work on this until the break bell rings and start going over it. Okay, so I started setting up the table here, put actual on the left, drawing on the right. Actual drawing is 4.5 feet to 1/8 inch on the drawing. So the first thing that I'm going to do is figure out what my scale ratio is, or what my constant of proportionality is. Will my scale ratio in this problem be the same as my scale factor? Emily, will they be the same?
It won't be the same because you have to convert.
Right, so they will not be the same. So when I find my scale factor in part B, I'm going to have to convert first, but I'm just going to find the constant of proportionality, or the scale ratio, for this table. Haley, how would I find the scale ratio, or the constant? What do I do? No, you don't multiply to find the constant. You do what? To find the constant, you do y over x. There we go. It's like the answer to everything in this unit is y over x. If I ask you a question, you have a pretty good chance of getting it right if you just say y over x. So y over x is, here's our y. This is our y. Here's our x. So 1/8 divided by 4.5 will give us our constant. 1/8 divided by 4.5. What does that come out to be? Did anyone do that and find the constant there? Kate?
1 over 36.
1 over 36. So we get the K is 1 over 36. And I'm not going to go through the actual multiplication here. You guys know how to do that. Okay. Or, I'm sorry, division. So we know that the constant is 1 over 36. So if we want to go from the right side to the left side of the table, do we multiply or do we divide?
On the left side or the right side?
No, we know the right side. We want to know the left side. So do we multiply or divide? Bella?
Multiply?
No? Charlie?
Divide.
Divide, yeah. It's kind of funny. If it's not multiply, obviously it's divide. But Charlie knew that because his hand shot right up. So we need to take 3/8 divided by 1 over 36 in order to find this. So when you go from left to right, you always multiply. When you go from right to left, you have to divide. Divided by 1 over 36, which is the same as multiplying 3/8 times 1 over 36. What do you get? Anyone have an answer? Charlie?
I got 27 over 2.
Okay, good. You get 27 over 2. What does that become as a mixed number? Mhm.
13 and a half.
Good, 13 and a half. So the actual door is 13 and a half feet wide for the actual mall entrance. Bella,
We did it a different way.
did you still get the same answer?
Yeah.
What did you do?
We did 4.5 times 3 over 1. Since 3/8 and 1/8, we just do that 3 times.
Okay, so you were looking at, yes, that works. So you were looking at how this 3/8 is 3 times larger than 1/8, right? And so you did 4.5 times 3 to get 13 and a half. Yes, that works because that relationship is true in a table that is a proportional relationship. Okay, so that answers our question, I think. Will the panels fit into the mall entrance? Yeah, they're 10 feet and the mall entrance is 13 and a half feet, so yes, they will fit. Okay, now we found the scale ratio to be 1 over 36. That tells us that the drawing is 130, or does it tell us that? Does it tell us that the drawing is 136 the size of the original? No, what do we need to do to find that out? Nope, doesn't work this time. Nice try. What do we have to do? We have the scale ratio. Why is the scale ratio not the same as the scale factor? Ava?
Because the original, or the actual, is in feet and the drawing is in inches.
Right, it's in feet and the other is in inches, so the units are not the same. So if we were to change this, this is telling us that 1 inch represents 36 feet. So to find a scale factor, we need to change 36 feet to inches. Let's see, Kate, I know you did that. How many inches within 36 feet?
How many inches? 432.
432. So the actual scale factor would be 1 over 432. So that's telling us that the drawing is 1/432 smaller than the original, or it's a whole lot easier to say that the original is 432 times larger than the picture. It's easier to state that the other way. Okay, any questions before we close out the lesson?